Okay, so today I'm going to be talking about factoring polynomials. We're going to start with looking at the monomial, which is a polynomial with just one term. Then we're going to look at factoring binomials, and then factoring trinomials, so one term, two terms, and three terms. So let's get started. When we're looking at monomials, we're looking at just something like it's a polynomial expression with just one term. Okay, so it's going to be something like this, like 2x, alright, or something like maybe 7x squared, or 3p, or something like that. These are all monomials. Now, with monomials, there's not really anything you can do to factor these or to basically see where they came from. And we'll take a look at this. Let's look at the most complex one I wrote there, 7x squared. And if you look at where that came from 7 and x squared, and x squared came from x times x. And so really when we look at this, it's 7 times x, which is just 7x squared. So there's nothing you can really do with that. So can't factor monomials. Okay, when it comes to binomials though, it gets a little bit more interesting. And often it depends on what you're going to do is dependent on the form of the binomial. So it just depends how it looks like. But one technique I'm going to show you today is just looking for a common factor. Okay, so what we're going to do here is we'll just start off with something like x plus 7. Oops. Okay, let's take 2x plus 14. This is what I meant to do. Okay, so 2x plus 14, and what we're going to do is we will see that this term is divisible by 2, and this one is divisible by 2. So the greatest common factor is 2. Okay, so what we can do then is pull 2 out of this. So we say this is the same as saying 2 times x plus 7. Okay, so as you recall from the previous videos, which I hope you've watched, there is something called the distributive property. And the distributive property of multiplication means that when you multiply something in brackets, everything within the brackets has to also be multiplied by that. So if you multiply this back, we'd have 2 times x, which is just 2x, and 2 times 7, which is 14. And you can see we got back to the original equation. And so what this means is that 2 times x plus 7 in brackets is the factor, are the factors of 2x plus 14. Okay, so really what we're trying to do is we're just trying to look for the greatest common factors and see what is like what we can pull out of the equation. Okay, so for instance, might have something like this, 32x squared plus 16x. Okay, and this is a little more complicated, but it's still not too bad. And what we can do is we can see that the greatest common factor of this is 16x. Okay, so they're both divisible by 16, and they're both divisible by x. So what I can do is pull a 16x out. Okay, what I'm left with here is a 2x, okay, and plus 1. Okay, and that's it. So really what you're looking for is the greatest common factor. Now, it could be that you just don't know what the greatest common factor is. And so you just might choose one, or what you can do is just start pulling out any factor you can see, and then just keep pulling out factors as you see them. Okay, so for instance, if I had something like 36xy plus, let's say 32x, okay, well, it's not really apparent what the greatest common factor is here. Okay, so what we can do then is we can say, well, you know what, I know that there's an x in both of these, so I can take that out. And I know that both of these are divisible by 2, so I can pull that out as well. So let's pull out just a 2x and see where that takes us. So we got 2x times, now if I take away 2, or divide this by 2x, I end up with 18y plus 16. Okay, now clearly this is also divisible by 2. still, so I can pull another 2 out. Now what this would be is 2 times 2x, and this will become 9y plus 8. Okay, and now the 2 times 2x on the outside becomes 4x, so 9y plus 8. So you can see what happens is as you go, you don't have to pull it out all at once, but you just have to keep multiplying as you pull factors out, and then you can still get to the correct answer. Okay, so the next thing you're going to do is we're going to look at factoring trinomials, and we're going to look at something called the distributive property. We're going to start with that and something called the FOIL rule. I hate personally hate the idea of the FOIL rule, although some students find it handy, and I will discuss why. But overall, if you understand it as a distributive property, it's probably better. Okay, so let's see. Let's start off with a general form for binomial multiplication. So let's say x plus a and x plus b. Okay, and so x is our variables, and a is a constant, and usually a numerical constant, so is b. Okay, so what this would typically look like is something like this: x plus 2, and then x plus 3, or something like that. Okay, where the x's are variables, and the a and b numbers are numbers. Okay. So what would happen if I multiply these together? Now, the distributive property tells us that what we have to do is we have to distribute all of these amongst all of these. Okay, and so what this means is basically a good way to think of it, or a way of thinking of it, is thinking that all of the items in this bracket have to associate with all of the brackets, or they have to like shake hands or something with all of the numbers in this one. Okay, so what we do is we have x has to multiply by x, so we're going to get x squared. And then x has to multiply with b, so we're going to get bx. And then x is being multiplied with everything here, so then we can just go to a. And this is going to be a plus ax, and then plus ab. Okay, and then what we can do is we can combine like terms, and these two are like terms because they have the same variable. Okay, so this becomes x squared plus, and then this would be a plus b x plus a times b. Okay, and this creates what's called what I'll call the general equation for a trinomial. Okay, now I'll show you this with the FOIL rule. And we'll get the same thing, but just don't like it called the FOIL rule. It's just kind of an odd name. Okay, so FOIL stands for, I'll write it over here. FOIL is an acronym, stands for first, outside, inside, and last. Okay, so the first term means that you have to multiply this one with this one. Okay, and then the outside one means you have to multiply these ones, and then the inside ones means you have to multiply these two, and the last means you have to multiply the last two terms in each one. So you have the first ones, then the outsides, the insides, and the last one, and it's a way of just kind of knowing how you can multiply it. But if you just understand that this x has to multiply with everything else in the other bracket, and so this a also has to do the same thing, that's a better way of understanding it. Okay, so we have this general form, and what we can do is we can take a look at a few examples here and see how this would work in practice. Okay, so we'll start off with the simplest one. Okay, we can have x squared plus 2x plus 1. Okay, and if we're following our general form, we get x squared plus a plus b x plus a times b. Okay, and what this would mean is that I can get an equation I can get two equations from this. Okay, by looking at the numbers that are associated with things. Okay, and so what I can find here is that a plus b is equal to 2. Okay, because it must be, because a plus b is this middle coefficient, and 2 is this middle coefficient. And then a times b is equal to 1, because this final one is also equal to 1. Okay, so what I'm looking for is two numbers that multiply to 1 and add to 2. And what we can find is that a is equal to 1 and b is also equal to 1. Okay, so that means that the solution to this is, and this is the same general form always, is x plus 1 and x plus 1. Okay, and if we were to multiply this out, what we would get is x squared plus x, and then we multiply this term and this term, we get another plus x, and then the last two constants we get plus 1, which would be x squared plus 2x plus 1. Okay, so let's take a look at a little more complicated example. Okay, so what we got is, let's try something like x squared plus 7x plus 12. Okay, now what we can do is we can start off by looking at the factors of 12. Okay, so 12 is equal to 1 times 12, 2 times 6, and 3 times 4. Okay, and what we can do is we can look at these as number sets. So I can use, in my final answer, I have some x and another x, okay, two binomials. And what I can do is I can use the 1 and 12, the 2 and 6, or the 3 and 4. Okay, I can't use like 3 and 6 because they're not pairs. Okay, so you have to use them in pairs. Okay, so I'm looking for a set of numbers. Now each one of these pairs already multiplies to 12. So I'm looking for a set of these numbers that I can make a 7 out of. Okay, and they have to add to 7. And what you can find is that 3 times 4 does that. So I can get x plus 3 and x plus 4. Okay, and that is the answer to this problem. Okay, so when you multiply them back, you get x squared plus 3x plus 4x plus 12, which is x squared plus 7x plus 12. Okay, and that's that. Okay, let's go to a little bit more complicated problem here. Okay, so we're going to go to something like x squared plus 3x minus 18. Okay, so when we're doing this now, it's a little more complicated because we have a negative number here, but it's really just the same. What we do is we start off again by starting off our binomials. So we got x and x, and then I'm going to list the factors of 18 again. So I got 1 times 18, 2 times 9, 3 times 6, and that's it. Okay, so what I'm going to do is I'm going to look for a pair of numbers that can add up to 3. Now it might not be readily apparent which ones are which, but what we can do is we can get an additional clue by looking at the signs. Okay, now if you look at this general equation, okay, the last numbers here, okay, are the result of multiplication. And so this negative 18 had to be a result of multiplication. Now this means that there's only one way that you can get a negative number here. So if this had been negative and negative, so x minus something and x minus something, when we multiplied these two numbers, they would have become positive. So this negative could not have been there. Okay, so they cannot be both negative. Okay. On the other hand, if they had both been positive, then it still couldn't happen because when these two numbers multiplied, they would become positive, and so you couldn't get a negative 18 there. Okay, so instead, what it is that one of them has to be positive and one of them has to be negative. Okay. Now, you can get another clue from this number. Okay, now I'll draw this in a different color here. Now this number is a product of addition, okay? And so this one has become positive. So this plus 3. What it means is that when you have A and B and one of them is negative, basically the larger one has to be the positive one in order to get a positive result. Okay, so for instance, in this case, we'll finish the question and I'll talk about this. It has to be that the 6 is the positive one, and the 3 has to be the negative one. Okay, and we'll take a look at this. So I have x times x is x squared. Okay, and then x times negative 3 is negative 3x, and then 6x, and then minus 18. Okay, and what I get is x squared plus 3x minus 18. Okay, just get rid of this here. Now, if I had gotten these reversed, okay, so if I had said that the bigger one in this case was negative, okay, when I multiplied it through, I'd get x squared plus 3x minus 6x minus 18. So the minus 18 would match up, okay, and so would the x squared, but when I had plus 3x minus 6x, I'd get negative 3x, which doesn't match the sign. Okay, which means that it had to have been, the larger number had to have been positive. Okay, hopefully that makes some sense there. Okay, let's go and try a different one here. Let's try x squared minus 5x minus 14. Okay, now there's some things that we can see here. The first one is that because this ends in a negative, okay, that the 14 is negative, it has to be that one of the binomials is x plus something and the other one is x minus something. Okay, that's the only way you can get a negative on the end. Okay. Now, take a look at the factors of 14, which are not too many. It's 1 times 7, or 1 times 14, and 2 times 7. Okay, so what I'm doing is I'm trying to find a way to get a 5 out of this. Okay, and what I can see is I got 7 minus 2 would make 5. Okay, now, which is the bigger one? Okay, well, the bigger one has to go here, okay, because it's a negative 5. Okay, and so this has to be a negative 7 plus 2. Right, and that would give us the correct answer there. So we got x plus 2, x minus 7. Now, it also doesn't really matter if you wrote it in the other way, like this, x minus 7, x plus 2, because multiplication also has something called the associative property, which means that it doesn't matter in which order you associate the factors. So either one of these is correct. Okay. I have one last one here for this set, and it is x squared minus 10x plus 16. Okay. Now again, we set up our binomials, and what we can look at is first we want to put the signs in. Okay, now this negative here means that when we add these two numbers, they come up to a negative number. Okay, which means that at least one of them has to be negative. But when we multiply them, they become positive. So that means that they both have to be negative. Okay, and then what we do is we find the factors of 16, which are 1 and 16. 2 and 8, and 4 and 4. Okay, and which ones we have? We want to get a 10, and what we can see is that this is the pair that we want to use. Okay, so we have x minus 2, x minus 8. Okay, and that's that. Now, there is a special case of this. Okay, and one thing, I can show it to you here. So we have x squared minus 16. Okay, so this is one example of a special case here. And a lot of times people get confused about this because they'll say like, oh no, there's no middle term. Right, so we have this term, which corresponds to this, And we have this term, the constant, which corresponds to over here. But what happened to the middle? Okay, so what happened is that the middle got eliminated. It's actually there, x squared plus 0x minus 16. Okay, so it is actually there. Okay, but what this is this is a special case of the polynomial or trinomial decomposition. Okay, and what this is called is a difference of squares. Okay, so what we have here is we have x plus 4, x minus 4. Okay, and they have to be the same number. Okay, and one has to be positive and one has to be negative. Okay, otherwise they won't eliminate. Okay, so let's take a look at this. We have x squared minus 4x plus 4x minus 16. Okay, and you can see what happens here is that we have a minus 4 and a plus 4x. Okay, and when we combine them, they're basically going to eliminate each other. Okay, and so then we'd end up with x squared minus 16. Okay, and this is the case all the time when you have difference of squares. Okay, so this is called the difference of squares. Okay, now why is it called difference of squares? Well, it's because x squared is obviously a square. Okay, but 16 is also a square. Okay, so what this means is that this is 4 squared and this is x squared. Okay, and so that the answer has to be x plus 4 and x minus 4. Okay, that's always how it is. So you can use the other method as well that I showed you, but this is, if you recognize the difference of squares, it makes factoring out really easy and a lot faster instead of having to go through the whole thing of finding the factors and adding them to be 0. Okay, so as I said, it's called difference of squares because each one is a square and you are subtracting them. Okay, to give you another example of this, let's say we had x squared minus 36. Okay, well, x squared minus 36, we have x squared, which is obviously a squared, and 36, which is another square. This is 6 squared. Okay, and this is x squared. Now, sometimes teachers or instructors will try and get a little bit tricky on you. Okay, and they'll throw something like this at you, x to the 4th. Okay, this is still a difference of squares. Okay, that this is x squared squared. Alright, so when we do this, what we would find is that the solution is x squared plus 6 and x squared minus 6. Okay, so it's still the same difference of squares. We just take whatever is being squared in there, and then what we'd have here is this one where we can't do anything with it, and this one where we still can't do anything. Well, technically you can here, but I'll show you that in just a minute. Okay, let's take one last one, and I'll use this example, a similar one, x to the 4 minus 81. Okay, now what we have here is that, as I said, this is x squared squared minus 9 squared. Okay, so when we factor this, this would be x minus x squared minus 9 and x squared plus 9 and x squared minus 9. Okay, it doesn't really matter the order that you put them in. It's just I want to be able to write off to the right hand side, and so that's why I'm positioning it like this. Okay, now the x squared plus 9 is stuck there. You can't do anything with that, so we just leave it. But the x squared minus 9 is a difference of squares again. So this is x plus 3 and x minus 3. Okay, and that would be as far as you can factor this. Okay, now one of the things that you should be aware of is when people combine these. Okay, Okay, so for instance, if we had something like 3x squared plus 9x minus 30. Okay, now when you first look at this 3x squared is probably going to give you a heart attack, okay, or it's going to disturb you. So, but what you should be able to notice is we go back to the greatest common factor thing that we saw with the binomials, and you can see that all of these are divisible by 3. So what I can do is I can pull a 3 out of each term, and I would end up with an x squared here, a plus 3x here, and a minus 10. Okay, and all of a sudden it just comes back to being the same thing that we've done before. So this is 3x times something, or x plus something, or x minus something, or whatever. Okay, and you can see this being a negative means that one of these is positive and the other one's negative. Okay, and so we look at the factors of 10. We have 1 and 10, and 2 and 5, and what we have is x plus 5, x minus 2. Okay, and this will be our answer. Okay. So a lot of times what we have to do is look for multiple types of factoring and not let big numbers scare you. Other things that people can do is throw fractions in there, put other squares in there so it doesn't look like it is, like it's actually squares, but it actually is. Yeah, you just have to get used to them, but don't let the numbers intimidate you. The first thing you always do is look for common factors that you can pull out. Then the next thing you do is check to see if it's a difference of squares. If it's not a difference of squares, then you just go to your regular trinomial factoring. Right? So that's the first lesson in polynomial factoring. If you have any questions, drop me a line, send me an email, or contact me in some other way, and I'll try and help you.